Okay, morning class. Hopefully we will begin soon. Okay, so if you are there, please say good morning, and then from there we will start live soon. Okay, morning class. Soon we will begin. Hopefully y'all can hear me. Can all of y'all hear me in YouTube and in Zoom? Okay, in Zoom there's only two of y'all. So yep, for those who are on YouTube, if you guys want to still join the Zoom, you still can join. Well then, can hear?
Yes, sir.
Okay, good then. I'm still waiting for the others to join. So once the others join, then we can start. Sharp 10 o'clock, we start with chapter 5. Huh? Okay, so please be ready. For those who are in YouTube there, you can just say some positive words. Okay. Hopefully you all are not in Langkawi. Yeah? Today Langkawi open right for holiday. Okay, for those who in Zoom, I think you can see the chapter already, which is already in front of you. I already sent the PDF document in the lecture group. So, yeah, the document also is with you. Okay, so soon we will start again. Just for those who are already here, please be patient a while. We will start while we wait for our friends line. Well, we'll be doing chapter 5 today. So, yep, please prepare yourself with chapter 5 notes. Okay, hopefully your friends will join us soon. Then we can start straight. Okay, I'm going to share what we are going to do today. So, yeah, I think everybody can see the sharing. Now, those in YouTube also can see, and those in what is this called, on Zoom also, you can see the thing. Betulkah jawapannya over 4 digit? Setuju? Di sini ada lihat bahagian B, kita ada sedikit cabaran sebab dekat sini 16 darjah 30 minit. Jadi kita kena convert dia punya minit kepada degree. Anda tengok nota ni. Each degree is made of 60 minit. So maksud 1 degree adalah bersamaan dengan 60 minutes. Each minute is made up of 60 second, kan? So sekarang ini kita akan lihat macam mana. So 30 minit, so kita akan convert kepada 30 minit bagi dengan 60. Berapa ya? 30 minit bagi dengan 60. Okay, soon we will start. Just waiting for your friends to enter, and we can start live. Okay, chapter 5 So 16.5 baru yang kita darabkan dengan Still waiting. If you can call your friends to enter as soon as possible. Then we can start fast. Okay, we have 4 more minutes before we start.
Check nanti bahagian C, so saya tinggalkan untuk anda. Saya nak bahagian D seperti yang ini, dia adalah minit, maka kita boleh tukarkan dia kepada D. So kita akan darabkan 15 bahagi 260, berapakah 15 bahagi 260?
Okay. Still waiting for the others to come in, and I will start straight away. So, yep, give them 2 more minutes. Okay, Arifa, good morning. Siti, good morning. Fatin, good morning. Ain, good morning. Okay. Okay, for those who are on YouTube, you still can join the Zoom. There is places in the Zoom still. So, yep. But well, if you prefer YouTube, no problem. You can stay there. Okay. Tan Yun Si, good morning. Siti Sarah, Radiatun, Nurin, Aisha, Nuriza, morning class. Ling Zing, Lim Chua Ze, morning. Kiranya, Calvin, good morning. Okay. Morning, Sarah. So just give 2 minutes lah. In a while we start. In 2 more minutes. I hope that I'm fine, PSG. I'm not that bad today. Good. Okay.
Delta ini kalau dia bergerak anti-clockwise, the values of theta is positive. Saya ulang.
Okay, I'm still waiting for the others to join the class so that we can start easily. Okay, and on time. So it's 1 more minute before the class starts. Huh? Okay, 1 minute. Let me just start. Okay, morning class. Let's start lah. Okay, today we are going to go into chapter 5. So I hope everybody is ready for chapter 5. And everybody is well doing. And it's a Friday. So yep, I understand. It's on a Friday where we should be actually be more relaxing and starting our work more with positive notes lah. Okay, chapter 4 we finished already. So now we go into chapter 5. Now under chapter 5 we are going to study about functions and graphs. So the main criteria over here is the graph. You must know how to draw the graph lah. Okay, know how to draw graph. Very important lah. Okay, very important. So make sure everybody know how to draw graphs. Okay. Now functions over here. So let's look over functions. What is functions over here? A function that is something that is defined that every element in a domain okay, has a unique image in the range. In other words, okay, a function is either the one-to-one relation or many-to-one relation. If you notice, it ends with the word one. Means one object will have one image, or many objects will have one unique image. Understand? Okay, so that is what function is all about lah. Okay. Now, another one more thing here also, we can see this is a many-one relation and this is an onto function. Okay, this is a many-one relation, but this is not an onto function over there. Okay, now what we see over here, this is example of functions which are not functions. Why? Because if you look over here, this is many, to 1, that is function. Okay, but then there is 1 to many also. Okay, 1 to many. So if this is 1 to many, this is not a function. Okay, so at the end of the day, this function here becomes a many to many function. Okay, this becomes a many to many function. Okay, and over here you can see this is a many to 1. So this is many to 1, but one object here is not matched to an image. So since the object is not matched to an image, therefore this also is not a function. They say every object must have a unique image. That's the definition of a function. Every object must have a unique image. So since that's the definition of a function, so since one object is not matched to an image, therefore this is not a function over there. Okay? Okay, so now what we can do is we can also see how we can test a function. We can test a function by using a vertical line test here. Okay, by using a vertical line test. If the vertical line cuts the graph at one point, therefore it is a function. If the vertical line cuts the graph at one point, then it is a function. If the vertical line does not cut the graph at one point, then it's not a function. So I hope you understand that. So please take note lah. Inside your my note should have lah. Vertical line test is to test function. Understand? To test function. Okay, if it cuts at one point, okay, therefore it is a function. Okay, it is a function lah. Understand? If it does not cut at one point, then it's not a function. So if you look at this graph over here, yes lah, this is a function. This also is a function. This is not a function, and this also is not a function. Why? Because it cuts the graph at two different points there. Okay, when it cuts the graph at two different points, one object have two images. So this is one to many already. So since it's one to many, therefore it's not a function. Okay, therefore it's not a function. Okay. Then we also have what we call as the horizontal line test. The horizontal line test is to test. Okay, to test it is a one-to-one function or not. Okay, it's very important to test that is this a function, this function is a one-to-one function or not. So for me to test this is a one-to-one function, we will use the horizontal line test. So if you look over here, by using graphical method, we know this is a quadratic function, x squared minus 2x. Therefore, we can draw a quadratic graph over here. This is a quadratic graph drawn. And you cut this line at one horizontal line here like this. You get 2 points which is cut. Therefore, this is not a one-to-one function. Okay, not a one-to-one function. If it cuts at 1 point, then it's a one-to-one function. Understand? So, if let's say in this case here, if I give you x equals to 1, okay, and I only consider this part of the graph, the purple color part, okay, the highlighted purple color part, then it's a function. Understand? For anything x, okay, more or equals to 1, therefore it is a function. Okay, or for x less or equals to 1, then it's a function. But for x, element of real, then it's not a function. Understand? For all the domain of x, then x is not a, the graph is not a function. I hope that is clear. Any question until there so far, class? Any question until there so far? Okay, so if you look over here, b here is a function. Why? Because it's a one-to-one function, because it cuts the line at 1 point only. So it cuts the graph at 1 point, therefore it is a function, confirmed function. Okay, move on here. This is also it's a horizontal line test. It's a one-to-one function because it cuts the line at 1 point over here. So this also is considered a function. Okay, but how about the d there? D is a reciprocal graph. This one is a horizontal line intersects the graph at 1 point also. Therefore, this also is a function because it intersects the graph at 1 point only. No matter wherever I cut the line, it will intersect the graph at 1 point only. Therefore, it's a function. But a modulus graph can never be a function. A modulus graph will not be a function. Why? Because it cuts at two horizontal points then. Understand? It cuts at 2 points over there. For the horizontal line test, it cuts at 2 points. So vertical line test is to test is a function. Horizontal line test, it tests Is this to test is it a one-to-one function or not? Okay, one-to-one function. Okay. Now, not only one-to-one function, it's also to test the inverse function exists. Okay, inverse exists or not. Why? Because inverse only exists if it is a one-to-one function. Okay, inverse only exists if it's a one-to-one function over there. So I hope that is clear for everybody lah. Any problem until there so far? Okay, any problem until there so far? Yeah, class, any problem? Still waiting for response. I hope everybody clear with this. Yeah, say. Any question so far? Oh, I can't hear you. Can you speak up? For those who have question. Okay, since no question, far is one-to-one function, no inverse, is it? No. If it's not a one-to-one function, it has no inverse. That's correct, Venusha. Okay, if it is not a one-to-one function, then therefore it have no inverse lah. Okay, that's right. Okay, only one-to-one function have inverse. Only one-to-one function have inverse. Okay, so I hope that is clear lah. Okay, very good then. So if no problem, I move on. Okay, I move on. Now let's look over here. Okay, give your answer. Which of the below diagram illustrate a function? So if we draw a vertical line test over here, this is a function. Yes or not? Okay, but is this a one-to-one function? Not a one-to-one function lah. So this is a function, but not one-to-one. Okay, but not one-to-one. And if I draw a vertical line test over here, that is very obvious that this is not a function. Why? For B is not a function. Okay, why? Because it cuts at two horizontal points. Yes or not? It cuts at two horizontal points. So not a function lah. Okay, 2 points. So cannot. Okay, and it's definitely not a one-to-one also lah. Here also, this is not a function. Okay, not a function. Why? Because it cuts at two horizontal points. This, yes lah. Okay, over here, this is a function. Yes lah. Why? Because it cuts at one horizontal point, one vertical point there. Sorry, it cuts at one vertical point. Okay, so I hope that is clear for all of you already lah. Okay, now we move on. The next part of this question here is how to sketch graph lah. So I will try my best to explain to you on how to sketch the graph in the way which I can understand and you can understand better also. Now, let's see a graph over here. We start with the most basic graph. Okay, I try to use the paper of box here so it's a bit more easier. Okay, we try to see the most basic graph here. Now, if you really understand the graph, okay, then it's very easy. We start with quadratic. Okay, we start with quadratic function. Let's say if I give you fx equals to x squared. Okay, fx equals to x squared. Fx equals to x squared, the most basic graph, we know that this graph is going to be a graph which is like this. Because here is 0. Yes, not here is 0. Okay, now if I give you fx equals to x squared plus 4, then no problem. You still can draw the graph. Okay, the graph here. Okay, the original graph of x squared plus 4 is here. But then the plus 4 over here means the graph is increased by 4. The graph is increased by 4 means the x-axis goes down by 4. The x-axis goes down by 4. So if I just want to rub off this x-axis and make this original x-axis as a dotted line over here, okay, and I go down the x-axis by 4, means 1, 2, 3, 4, go down, and I draw a graph here, a line here. This is your x-axis, this is your y-axis. Here will be 0, 1, 2, 3, and here is 4. You can see that? So you already get the graph of x squared plus 4 actually. The movement of your x-axis, that will give you the graph of x squared plus 4 then. Okay? Of course, you might tell me, sir, plus 4, you say move the x-axis down. Move x-axis down by 4. Okay? Down by 4. So how if I give you like this, y equals to negative x squared. Now y equals to negative x squared, you know your graph is going to be a set face graph. Okay, this one everybody know, right? This one you have studied before already. This is y equals to negative x squared. This is y, this is x. Okay, but now if I give you y equals to negative x squared minus 4. So no need to worry, you know one thing, that the graph will move, the x-axis will move up by 4. The x-axis will move up by 4. The original graph is here. Okay, maybe I can just draw it a bit lower. Okay, here. So here is the original graph. This is your original graph. Okay. Now I'm going to rub off the x-axis. See, I move the x-axis. Huh? So here, now since it's negative 4 means move up by 4. Okay, move up by 4. So if I move up by 4, this is going to go up 1, 2, 3, 4. Means this is what you're going to become. Here is your new x-axis. And here is negative 1, negative 2, negative 3, and negative 4 here. And it makes complete sense because this is your C. This is your C, negative 4. See, it cuts at negative 4. Okay, here is also 4. It cuts at 4. Can see that? Understand? Of course, this is not the best way to draw a quadratic graph. The best way to draw a quadratic graph, there is 5 steps to follow. So let me just go through the 5 steps with you so that you know and you understand. Okay, the best way for me to draw a quadratic graph over here is like this. Let's say fx equals to x squared plus 3x, the one, yeah, 3x plus with 2. Okay, plus with 2 over there. Or let's make it negative 3x. This will be easier. Okay, so since it's negative 3x plus with 2 over here, I know that the best way to draw this graph is going to be by completing the square. Why? Because the first step is I make sure a equals to 1. So a is 1, positive graph. So a is more than 0, therefore it's a smiley face. Okay, if a is less than 0, it will be a sad face. A less than 0, it will be a sad face. The second thing you have to do is complete the square. So x square minus 3x plus 2. You complete the square, you get x minus 3 over 2 square minus 9 over 4 plus 2. This one you learned before already, how to complete the square. In form 4 also got learned. So minus 9 over 2 plus 2 over 1 there, 4 times 4, negative 1 over 4. Okay, so you already get completing the square already. The third step is go and find your y-intercept. Your y-intercept means x becomes 0, so 0, 2. The fourth step there is find the minimum point. Okay, the minimum point here is 3 over 2, negative 1 over 4. This point over here, this 3 over 2, you take out, becomes positive 3 over 2. And negative 1 over 4 here is the y value. Okay, so I hope that is clear for everybody. Okay, that is clear. And then number 4 over here, the fourth step over here is going to be find your x-intercept. Sorry, number 5, my mistake. Number 5 over here is find your x-intercept. Of course, your x-intercept means you just press your calculator, x squared plus 3x or minus 3x, that's now I gave, plus 2 equals to 0. So from here, you can tell me x minus 2, x minus 1 equals to 0, x equals to 2, and x equals to 1 then. Can see that? Okay, so from here, I can straight away draw the graph right now for you. Okay, I can plot the graph for you a little bit. Okay, see, I got my minimum point already. My minimum point is 3 over 2. This is 1. And let's make it this way, I think better. Okay, this is 1. This is 2. Okay, so I know 1.5 is somewhere here. Negative 1 over 4 is going to be somewhere here. Okay, I know it must cut at 1 and 2. So 1 and 2. And I know it must cut at the y-intercept of 0, 2. So 0, 2. 0, 2 is here. This is 1, this is 2. So my graph is going to be something like this. Okay, of course, you can draw the axis of symmetry here. Okay, it's a U-shaped graph. It's a U-shaped graph over there. That's it then. So the best way to draw a quadratic equation graph is by completing the square if you got 3 terms. Okay, if you got 3 terms. If you got 2 terms, then you just move by the axis. You just move by the axis over there. So I hope this is clear for all of you all lah. So after this, you all can try sketching all the quadratic graph which I've already given to you all. Okay, then the next one comes to a cubic graph. Okay, the next one comes to a cubic graph. Be there, cubic. So under a cubic graph, that's very simple. Actually, is power of 3. Okay, power of 3. So any power of 3 graph, if I give you y equals to x cubed, positive graph, it will be like this. Okay, it's a S-shaped graph here. Okay, my drawing hopefully is nicer a little bit. Yeah. Okay, this is an S-shaped graph. Okay, and let's say if I give you y equals to x cubed plus 4, or the one plus 4 lah, let's make it plus 2 right now. You know plus 2 means the x-axis move down by 2. Okay, move down by 2. You don't move the graph, you move the x-axis, understand? So if you move down the x-axis by 2, indirectly you are moving the graph lah. This is the original graph here. Okay, this is the original graph. You move down the x-axis by 2 means you're going to go down by 2. So I can rub off this. You don't need to rub. You can just put it as a dotted line. Just put, you are drawing with pencil, right? Not. Okay, so you can rub it and make it a dotted line over here. Move down by 2, and then from there, okay, so from here you can get here. Okay, so 0. Okay, here is 0, 1, and 2. You can see that. Very obvious. This is your new x-axis. Now move down 1, 2. So I hope that is clear for everybody. So you already get your y equals to x cubed plus 2 graph. Okay, y equals to x cubed plus 2 graph. Any problem under here? So if you notice one thing, where the y-intercept is, that's where they change lah. The direction change. You see here is like this. Then where the y-intercept is, that's where the direction will change. Can you see that? So I hope that is clear for everybody. Any problem? Okay, of course you have to write the x-intercept and the y-intercept. Okay, the x-intercept and the y-intercept, if you can find, you have to write lah. In this case here, the x-intercept is going to be negative cube root of 2 lah. Why? Because x cubed plus 2 equals to 0, x cubed equals to negative 2, therefore x equals to negative cube root of negative 2 lah. Understand? It's equals to negative, cube root of negative 2 over there. Any problem until here so far, class? Anybody got problem until here so far? Everybody clear? Okay, those in YouTube, are you all clear? Can see how to sketch the graph of cubic? Okay, can okay, of course the graph of cubic does not only apply this way. We also have something a little bit more extra over here. We can see that the graph of cubic I can give for y equals to negative x cubed also lah. So y equals to negative x cubed, of course the graph reflects back. You see, negative means it reflects on the y-axis, x-axis, sorry. Any negative graph, it will reflect on the x-axis, so it's going to be like this. Understand? That is the negative cube graph. Clear? Okay, so if I want to draw back over here, so can actually, but never mind, I just draw here. It reflects on the x-axis. Negative in front here means reflect on x-axis. Understand this thing. Very important to understand this thing, so that any graph they give you, you know how to do after this. Understand? Reflect on the x-axis here. So if you reflect on the x-axis, this is what you're going to get now. Can see that? So this is y equals to negative x cubed. Okay, y equals to negative x cubed. So if I give you now y equals to negative x cubed plus with 2, or the one plus lah, just now we did plus, so let's put minus lah. Minus with 2, you know the y-intercept is negative 2, what, right? Not? You know the y-intercept is negative 2. Let's just draw the negative graph first. This is the original graph. Now you have to move out the x-axis. So the x-axis, if I move out, I put here dotted line. Negative 2 means move up. If move up means here is your x-axis. Here will be your y-axis. Negative 1, negative 2. Again, the same thing. You can see very clearly. wherever they cut the y-intercept, the moment it cuts the y-intercept, the graph changes sign. The graph changes sign. So over here is going to become negative cube root of 2 also. Okay, negative cube root of 2 over there. So I hope that is clear for you. Any problem until there so far? Everybody okay? Can? Okay?
Okay, sir.
Can, okay, good. Just to go back a little bit onto the quadratic graph just now, here we can ask you the range. What is the range over here? The range is the lowest value go up to the highest value, or go down the highest value to the lowest value lah. Understand? The highest value to the lowest value. Again, I go back. Okay, so the range here is negative 1 over 4, am I right or not? Okay, so the range over here is represented by all these green color graph here, this green color or blue color line, greenish blue here. That is the range on the y-axis there. So the range over here is given by fx, okay, more or equals to negative 1 over 4. Make sure it's in curly bracket because it's a set. Understand? Because it's a set of values there. So fx must be greater or equals to negative 1 over 4. Of course, you might tell me, sir, how about this one? This one, very obvious. You can see this part here. This is the range down here, right? Okay, so here the range is going to be fx is lesser or equals to negative 4. That is the range. Okay, if I go up here, this part here, the range is going to be more than 4. So the range over here is fx more or equals to 4. What about the domain? Domain is every value lah, every x value which exists, everything here, understand? Or all of these values can so all of these value is just the real number lah. So the domain for all of this graph, okay, for domain for all of these is x is the element of real. Understand? The domain is just x is the element of real over there. So for all the graph there, the domain is the same. Understand? The domain here is the same. I hope that is clear for you all. Any problem until there so far, class? Can? Okay. Same goes for here. The domain is what? The domain is going to be all the x values there. So the domain over here is just x is an element of real. So remember in my assignment, I told you all to write down. I want you all to write down this line. Okay, write down the domain, the range, the the inverse. So all that must write. Clear? You can write in interval form also, no problem. But I prefer you to write down like this so that you know that this is a set of values lah. Must be in the form of set. Okay, must be in the form of set. In short, clear with that? Any question until there some more so far? Anybody got any question until here so far? Okay, if no problem, then I want to move on and carry on. Can I move on? Can I? Okay, good then. So let's carry on. Okay, let's carry on next there. Okay, now after we finish this, we have the next graph which is called the surd graph. So if you look at the surd graph over here, it's not that hard anymore already because we know the concept already. The concept is basically very easy. Okay, we look over here, see if I give you y equals to surd x, you know that this is just going to be like this, the surd graph. Okay, surd x here. Of course, if I see consider plus minus, then with bottom here but we are not considering that. We just consider here surd x here. Okay, so now if I give you y equals to surd x plus 4 or plus 1, let's make it a little bit easier. Simplify, plus 1 over here, you know the concept already. This is my original graph. Plus 1 means my x-axis must move down. That is my graph, that's my original concept, right? So plus 1, my x-axis move down. So here you go. This is your new x-axis. This is 0, this is 1, this is 2, this is 3, this is 4. So you can tell me the range over here is going to be fx is greater or equals to 1. Okay, why? Because everything above, yes or not? Everything above here. So here. Can you understand that? And when x is 0, square root of 0 is 0, 0 plus 1 is 1. Can you understand that? So that's why very clearly that you can see how the range is defined. Of course, the domain is defined by you. Lah. So the domain over here, x must be greater or equals to 0. Why? Because domain cannot take place of negative values. What, right? Not negative offset does not exist. So here there will be no graph. No matter how you draw also, there will be no graph. You see? If I draw like this also, there is no graph on your left hand side there. So there is no domain over there. There is no x over there. Understand? There is no x over there. The domain will not exist for that. Clear with that? Okay. Now let's say here, if I give you like this now, square root of x plus 1. Now this becomes more interesting little bit. We still draw the basic graph, square root of x. Now it's plus 1. Now the plus 1 is inside the function. See, it's inside the function here. It's inside this x plus 1 here. It's inside the square root. Yes or no? It's inside the square root there. So over here, you know one thing. You cannot move the x-axis now. You cannot move the x-axis. You are supposed to move the y-axis. So where will you move the y-axis with? You will move the y-axis to the right. Understand? You will move the y-axis to the right. Why? Because you know that x plus 1 must be greater than 0, x or greater or equals to 0, so x is greater or equals to negative 1. So negative 1 can exist. So here is 0. Okay, here is 0. To make negative 1 exist, I move this here. So if I just rub this, I put the dotted line here. Okay, that is the lowest value I can get. So here is the 1, the y which I will move to the right. So this plus 1 which is in the function, this plus 1 here is already inside the function. It's inside the function. Therefore, this one we move the y-axis and we move to the right. Never mind, if you cannot see that, you can see that x plus 1 must be greater than 0. Therefore, x must be greater than negative 1. Right? So since x must be greater than negative 1, therefore we know that negative 1 can exist. So 0 will be here now. Oops, sorry. 0 will be here, 1 will be here, 2 will be here, 3 will be here. So now you can tell me the range is very obvious. Fx is greater or equals to 0. Why? The lowest value right here. See, the lowest value is 0, go up. Okay, but what is the domain? The domain is going to be x, x values over there. So x must be greater or equals to negative 1. That is how you get the domain. Can you all understand this or not until here? Any question so far? Any question until here so far? So if I tell you minus 1, y equals to square root of x minus 1, anybody can tell me move where? Where must I move the y-axis?
Move to the left.
Move to the left. Let's check line. Okay, your friend don't agree, so we check there, right? Okay, we check here. Y equals to square root of x minus 1 here. We check. So you know that this is the basic graph here. Here is your basic graph, square root of x. Okay, now you know that x minus 1 must be greater than 0. So x must be greater than 1. So if x must be greater than 1, so this 0 cannot be here, right? Not. So you move this to the left. So negative 1 is inside the function, therefore move the y-axis. Understand? We move the y-axis towards the left. So if you look over here, move y-axis towards the left. Drawing graph is not that hard actually, if you understand the concept. Okay, so if you move here, you get dotted line over here. Sorry, dotted line should be here, my mistake. Dotted line will be here. Okay, here will be your y. And here is your x. So here is 0, here will be 1, here will be 2, 3, and 4. Can see that? So the range or the domain here, domain is very obvious. X is greater or equals to 1. That's the domain. The range is going to be what right now? Range is going to be anything more than 0. Anything more than 0. So fx is still greater or equals to 0. Can you all understand until here so far? Any problem? Any problem?
No, sir.
Okay, can okay. So I can actually do another one more. Maybe I can just try to copy back this question here. Okay, I will just copy back this thing here. Okay, and draw here. Okay, so now let's say if I give you y equals to negative square root x minus 1. So you already draw square root x minus 1. This part here you draw already, which is this graph here. Okay, that is the graph there. So no problem lah. Okay, but they want negative. Negative is in front of the function right now. Negative square root x minus 1. So the negative over there, what will happen over there? Oh, the negative must reflect on the x-axis or y-axis. Which one? X or y? Waiting for a response. X-axis or y-axis? Yeah, reflect on the x-axis lah. So you reflect on the x-axis, the graph will be this graph here lah. Am I right? This graph will be here. So this is just fx equals to negative square root x minus 1. Understand? Because this is fx equals to square root x minus 1. So now you can see lah. Some of you all understand the topic already lah. Okay. Of course, the range for this, the range will be fx less than 0. Sorry, less or equals to 0. The domain remains the same lah. X greater or equals to 1. Okay. So I hope until there clear lah. Okay, the next function which we need to know is called the reciprocal function. Reciprocal basic function is like this. All of you all got learned this before in Form 5, yes or not? When you study graph. Okay, so this one you got learned before. You know this is the basic function of a reciprocal. But not all reciprocal function will be given like this. Some reciprocal function will be given like this. I show you. Hold on. Let's say if I give you y equals to 3x plus 1 over x minus 1. Now let's see how we can draw this reciprocal function here. Now when we want to draw reciprocal function, you need to find the something which we call as the asymptote. Okay, the asymptote. This asymptote is not your chemistry isotope. No, this asymptote is the graph where the graph cannot touch the function. Why? Because it becomes invalid. Okay, it becomes invalid. So here you know that x cannot equals to 1. That's the first thing. Then we also have to find for the y. Now pay attention how to find for the y. For y, it be y cannot be equals to 3. Don't believe? Let's look. I check for you here. Okay, 3 equals to 3x plus 1. Therefore, you get x minus 1 here. So you get 3x minus 3 equals to 3x plus 1. Cancel, cancel. You get negative 3 equals to 1, which is invalid. Understand? Which is invalid. So that's why cannot lah. Okay. Now, how did I get the answer straight away? Y cannot equals to 3. How I know that? How I know that is basically by using these points over here. See this point, 3 and 1. 3x and x there. So 3 over 1. So becomes 3, right? Not 3 over 1 becomes 3. That's why I know y cannot equals to 3 lah. Okay, now once you know that already, you just plot your graph here like this. Okay, you know that x equals to 1. So x equals to 1 is going to be here. Sorry, my mistake. X equals to 1 here. This is x equals to 1, 2, 3, 0, negative 1, negative 2, negative 3. And then y cannot equals to 3. So you just go up here a bit and you draw a dotted line up here. Okay, then you should know what is the y-intercept. The y-intercept means when x becomes 0. When x becomes 0, the y-intercept is negative 1. So negative 1 is here. So since negative 1 is here, I know one thing, that the graph have to be something like this. Okay, 1 and here. Can see that? I hope everybody is clear with that. If you want me to just shift this thing up here a little bit, I can shift. Maybe up here. Okay, so your graph will become like this. Okay, by shifting the thing just now. Okay, wait, just give me a second. Actually put the thing line for y equals to this. Yes, okay, here. Now can see the thing nicely. Okay, until there, everybody can understand this? Clear? Okay, I give one more, can? I give one more how to find the asymptote. Okay, how to find them asymptote. Let's see another one more. Maybe I give you y equals to 2 over x minus 1. No problem. You know that x cannot equals to 1. Okay, yeah, sir, why you give always the same one? Okay, I put x plus 1. So x cannot equals to negative 1. Okay, and then the y cannot equals to 0. How I know 0? Because you look over here have no x. So 0x lah. So plus with 0x, right? No, 0 over 1. 0 over 1 will give you 0. Understand? 0 over 1 will give you 0. So y cannot equals to 0. If you don't believe, you can go and press, you can go and substitute y equals to 0, you will get an invalid function. So x equals to negative 1 is here. Okay, this is negative 1. Y equals to 0 is here. Don't forget that. Your x-axis itself is y equals to 0. Your x-axis itself is y equals to 0. So if you put x becomes 0, you're going to get 2 over here. So you know your graph is here and also here. It have to be in the opposite direction. It cannot touch the asymptote, that's all. Understand? It cannot touch the asymptote. So any problem until here so far? Yes, to find the asymptote of x-axis, we have to use the denominator lah. That's very obvious now, pretty much obvious over there. Clear? Okay, that is to find the denominator of the x-axis there. Okay, Hatta, that's correct. Very good. Okay, Hatta asked the question. To find the asymptote of the x-axis, we use the denominator. That's correct. Okay, that's correct. We use the denominator there. Okay. Some more? Any more there? Any questions? Some more? If you got problem, then let me know. Okay, let's say another one more. Yeah, say.
So I'm still confused with the y.
Okay, y over here. This is 2 plus 0x, yes or not? So you take 0 over 1. 0 over 1 is what? 0, right? That's why y cannot equal to 0. And if you don't believe, you see here 0 equals to 2 over x plus 1. You bring up this thing here, you get 0 equals to 2, which is not possible, which is invalid, understand? Which is invalid. That's why y cannot equals to 0. Can you understand that? Clear, Jinsuan?
Okay, thank you, sir.
Okay, Jinsuan, right? Yeah, correct. Okay, so correct line. Okay, now I see another one more line. We see another one more. Come. Okay, how if I give you y equals to 3x or 1 minus 3x over 2 plus x there. So you know the x asymptote, x cannot equals to negative 2, yes not? Okay, what is going to be the y? Y cannot equals to, anybody? Y cannot equals to? Hello? Y cannot equals to?
Negative 3.
Yeah, y cannot equals to negative 3. Don't believe, can go and put y equals to negative 3 and you'll see it's invalid. Okay, so now from there we can draw this. Okay, I try my best to draw it as big as I can. Y equals to negative 3 is here. Okay, of course you might tell me, sir, we use single line paper, you use box paper, can lah. Single line also got lines, right? You can use the lines to become your scales over there. Clear? Okay, and x equals to what? Negative 2 here. So negative 2 is here lah. Okay, so negative 2, negative 3. This is your first quadrant, second quadrant, third quadrant, fourth quadrant. So now you must know where it will fall. So that will be given by the Y-intercept. So let's search for the Y-intercept. The Y-intercept is y equals to half. That is the Y-intercept here. You have to agree with this, right? Y-intercept is y equals to half. Okay, so if y equals to half maybe is here. So I know one thing, the graph is going to be something like this. Yeah, my drawing is not that nice, in this case here. Okay, maybe I should be able to draw something like this. Yes. Okay, and the opposite of the first one. So if this is the first quadrant, the opposite will be the third quadrant. So that's why you draw here. And that one you all should know already, right or not? Okay, that one you all should know already. Any problem until there so far? Can? So this is 0 lah. Okay? Okay, then it comes to the question of how if let's say they tell me like this now. Okay, y equals to 1 over x plus 4. Don't worry lah. If they give you like this, you make it like this lah. 1 plus 4x over x. You make it a single fraction before you draw. Understand? You make it a single fraction before you draw. You're still going to draw the same function, right now? Okay, so here you know that x cannot equals to 0, y cannot equals to 4. Okay, so you know that already. If you put it like this, okay, y equals to 4 is going to be up here. Oh, yeah. Draw, maybe I use 2, 4. Okay, I'm going to use the scale of 2 and 4 here. So y equals to 4 is up here. X equals to 0 is already the y-axis, right or not? X equals to 0 is already the y-axis. Okay, so now from there, if I make x 0, y is 1. Y is 1 is here. So y-axis is here. Oh, wait. My mistake. X cannot equals to 0. X cannot equals to 0 is here. Okay, and y cannot equals to 4. Y cannot equals to 4 is at the top there. And the y-intercept is 1. Yes or not? Okay, the y-intercept is 1. Okay. So with that said, let me just draw this thing out so I can see the quadrant. Oh, sorry, x cannot equals to 0. So there is no y-intercept. My mistake. There is no y-intercept at all. Okay, because x cannot equals to 0. So there is no y-intercept. So now from here, let's say if I put here 1, here 2, if I put 1 inside there, I'm going to get 5. 5 over 1. So which is 5, which is above here. Okay, so the graph is going to be somewhere here and also somewhere here. Because if y becomes 0, okay, x is going to become negative 1 over 4, which is here. Can you understand that? Clear until there so far, everybody? Okay until here? So until reciprocal graph, everybody okay? Okay, huh? Okay, so
not really
again?
not understand part yang as a
Yang ini ke?
Y-intercept. Yes.
Okay, the y-intercept cannot take place this time. Why y-intercept cannot take place? Because x cannot equals to 0, right? Y-intercept only exists if, let's say, x equals to 0. Sekarang, dia kata x tak boleh sama dengan kosong. So, kalau x tak boleh sama dengan kosong, maka y-intercept tak boleh wujud lah. So, sini tak boleh ada point. Faham tak? Atas y-axis itu tak boleh ada point. Clear? Tapi x-intercept still can exist, right? So, you can go and find the x-intercept or you just put one point lah. You can label any point, whichever point you want, you can add. Okay, 3, here negative 1, negative 2, negative 3. You boleh masukkan dan you akan nampak nilai dia memang jatuh kat sebelah situ lah. Boleh faham tak? Clear until then?
Yeah.
Okay. Why is it negative 1 over 4? Kalau y sama dengan kosong, okay, 1 plus 4x over x. So 1 plus 4x sama dengan kosong. So x sama dengan negatif 1/4. Understand that, Fairuza? Okay, that's why I get x equals to negative 1 over 4. That's why lah. Boleh, Fairuza? Okay, so that is the x-intercept basically. Kalau boleh cari y-intercept, cari x-intercept lah. Tak ada masalah. Okay? Okay, cool then. So I hope until there you all understand lah. I will send you all back this graph drawing so that you all can copy in your notes lah. Okay? Okay, so done with that already. Once we're done with reciprocals, we done also with this one. So now we go on to the next one here. Now you can see here there are a few graphs lah which we have to sketch lah. Okay, which you can sketch. Okay, or we can sketch together here. If you look at this graph here, this is a y fx equals to negative 5. fx equals to negative 5 is a constant graph. So this is a constant graph over here. That's it, done. Understand? This is a constant graph lah. Y, fx means y, right? Not. So y equals to negative 5. This is the graph lah. That's all. So label y equals to negative 5 over here. That's all. Boleh faham? Okay. So here is y equals to negative 5. I hope until here okay, huh? Okay. Now fx equals to negative x plus 2. So fx equals to negative x plus 2 here. This is fx equals to negative x plus 2. Here the gradient here is negative. Okay. This is a straight line graph. Any straight line graph for you to draw, you need 2 points only. Y, x there. So x0, x is 0, y is 2. And y is 0, x is 2. So you just plot that lah. You plot these two in your graph paper, sketch that lah. Kalau tak nak guna 0220, boleh guna apa-apa titik lain. Mungkin you, let's say you want to use negative 10, can, no problem. Put lah negative 10, negative x, negative 10 plus 2 there, you get negative 8. So negative 10 is here. Okay, negative 10 is here. Sorry, my mistake. You put, you get 12. My mistake here, calculation error. Okay, you akan dapat 12. So negative 10, 12 kat atas ni kan. 12, right? So plot lah. You need only 2 points to draw a straight line graph lah. And that one also you learn in Form 5 already when you draw graph, straight line graph. Yes or not? So that's right. Okay. Then quadratic, I told you the best way is to complete the square. So I already tell you the best way is to complete the square. Here x minus 1 over 2 square minus 1 over 4 minus 2. So x minus 1 over 2 square. Here minus 1 over 4 means 8 minus 9 over 4 lah. Okay. Now kalau tak percaya, tengok negative 1 over 2 here is the minimum point. So negative 1 over 2 is here lah. Okay, negative 9 over 4 is here. So negative 9 over 4 is here. Supposed to be here lah. The minimum point. Okay. And then after that, sorry, 1 over 2. My mistake. 1 over 2. Okay, 1 over 2, negative 9 over 4. Here is the minimum point. Okay. The y-intercept is negative 2. So the y-intercept is negative 2 down here. Okay. Up a bit. Yep. Okay. If I don't want to use this, I better use my own drawing here. Okay. Negative 2 is here. Okay. Positive 1 over 2, negative 9 over 4 here. You know that if I factorize this, x square, so you're going to get x plus 1, x minus 2 equals to 0. X equals to negative 1, x equals to 2. So negative 1 here and 2 here. So from here, you can see that this graph will cut here this way. And here is your axis of symmetry. Done lah. Okay, so x equals to half. So drawing quadratic graph actually also you learn in Form 4 already. Not say never learn lah. I'm just repeating for you. Okay. Now this is interesting little bit lah. So here this is x square minus with 2 minus x there. Okay, x square 2 minus x. So if I really look over here, this is a cubic graph. So x equals to 0, x equals to 0, and x equals to 2 are the factors. X equals to 2 are the factors over there. Because x square, x minus 2, 2 minus x equals to 0, you will get x equals to 0, x equals to 0, and x equals to 2 there. So from here, this is 2. 0 here repeat twice. So when the thing repeat twice, you have to touch and go. Touch and go. Now, you can of course differentiate this and get the answer for the maximum point there. So you all got to learn differentiation, remember? Okay, so this is y, dy over dx over here. This is going to become 4x minus 3x squared equals to 0. So if I take out x, I'm going to get 4 minus 3x equals to 0. So x equals to 0 is one turning point. The other one more turning point will be at 4 over 3. So the 4 over 3 is here. You turn over here. Understand? You are advised to turn over here. So turn and come down here. That's what. Right now, in this chapter, particularly, when you do, we don't really stress where the turning point is lah. But this is how you find the turning point, dy over dx. Understand? Dy over dx equals to 0. Understand? To get these points here, you make the whole equation equals to 0. Fx equals to 0 lah, your roots. Understand? Your roots. That's why you get x equals to 0, x equals to 0, x equals to 2. You will study this more in chapter 6 later. Okay, you will study this more in chapter 6 later. So hopefully this is clear for you all. Okay. Okay. Then square root x plus 5. This one just now I teach it, so I'm not going to do e. I'm not going to repeat that. Over here, you can very clearly see that x cannot equals to 2. That's why the asymptote is that. And y cannot equals to 0. That's why this is another one more asymptote over here. So from there, you just sketch the graph there. Okay, what does this modulus graph means? Now, modulus graph over here means that this graph is going to break up into two parts, which is like this. This is representing x minus 2, and this is representing negative x plus 2. Understand? One is representing x minus 2, one more is representing negative x plus 2. But in other words, modulus just means that whatever below the x-axis, you reflect up. Whatever below the x-axis, you reflect up. That's all. Understand? It doesn't mean anything else more than that. Clear? So even if I can put a modulus graph for this function over here, for square root, for square quadratic one. So the graph is going to become what right now? Like this. Then it will become like this, and it will become like this. So the modulus will be for the blue color line. You can see the modulus will be the blue color line part. Even let's say this graph over here, so I can put a modulus. This is the graph supposed to be originally like this, yes or not? But now since it is modulus, it will become like this. Understand? It will become like this over here. So this is how basically you see graph over here. So can you understand until here so far? Until F there, everybody okay? Until F there, everybody okay? No, after G, sorry, FG. Until G here, everybody okay? Any problem until here so far? Okay, okay. So with that said, yeah, say.
So we need to label the modulus like negative x plus 2 and x minus 2.
No. That one you need to label. This one you need to label. In the graph, you'll never label modulus. You just label fx equals to modulus of x plus 2. I am telling you that this is x minus 2. This is negative x plus 2. Because I can write down the function like this also. Negative x plus 2 modulus. The graph is still the same. Isn't it? Let me just see here. Yeah, the graph is still the same here. Understand? But then in this case here, this will be negative x plus 2. This will be x minus 2. Because here is positive 2. Can see that? Understand? So you don't need to label, but you have to, what? You must know lah where the thing represent. Clear? Okay, how about negative sign for modulus fx? Negative sign of modulus of fx means negative here. Yes, not outside here, right? Hatta? If the modulus is, the negative is outside here, okay, then the graph will be, first you draw the modulus, then reflect on the x-axis. Then only you reflect on the x-axis. So Hatta asked me if let's say like this. Okay, how like this? If I put a negative outside here. So of course you draw the modulus first. After you draw the modulus already, then only you reflect on the x-axis. So the pink color graph will become the modulus one. Y equals to negative modulus negative x plus 2. Clear until there? Remember, negative sign outside the function always reflect on the x-axis. Negative sign inside the function means f negative x. That one reflect on the y-axis. Can you understand that? Clear? Actually, in this case here, if I just consider this graph here is actually a reflection on the y-axis here. Okay? But reflection over here is the same thing. That's why you get that way. Can you understand that? Okay? Okay then, good. So your duty right now is to go and draw all the graph which I've given you. Understand? When you see the graph already, okay, when you draw the graph already, then from there you'll be able to see the range and the domain. So try to find the range and the domain first before we go and prove that how to see the one-to-one function. Okay, drawing the graph will help us find the range and domain. Remember one thing, the domain is always on the x-axis. Okay, the range is always on the y-axis. Understand? Domain is on the x-axis, range is on the y-axis. So here you can see the range here, the lowest value is -9, so more than -9 lah. The real value for domain is everything, all real value here. So every value can take place. Understand? If I take the square root graph over here, or the domain is more than 3 and the range is above 0. Can see that? Understand? Over here, all real value, but 5/2 cannot take place lah. The asymptote cannot take place. Understand? The 5/2 cannot take place for the domain. The range is all -infinity to infinity, but 0 cannot take place. Why? The graph cannot touch 0 ma? The graph will not touch 0 over there. So you can see all this graph over there, draw for you already. You can see how we determine the domain and range. Okay. The next lesson, we will carry on with algebraic method. So I already teach you graphical method. I want you to try with using graphical method. The next lesson, we will try to see algebraic method a little bit. Okay. To find domain and range, graphical method is always more helpful. Any problem until there so far, class? Can everybody? Okay. With that said and done, I think I will stop here today. That's all for today. And I will see you all Monday for the next topic. The next topic, which is called algebraic method. Okay. Thank you, class. Any problem? Okay. If no
No, sir.
problem.
Thank you, sir.
Okay. If no problem,
sir.
then thank you, class.
sir.
See you guys on Monday. Bye-bye. See ya.
Thank you, sir.
Okay.
sir.
Thank you.
Yes, sir.
Thank you. Thank you.
Sir,
Yes, say.
sorry nak cakap sir.
Sekejap boleh tak? Sekejap
Boleh.
Ya, nak cakap apa?